Okay, intro to sets. Okay. So we are finally done with statistics. Everything that I'm going to go ahead and discuss with you as far as IB is concerned when it comes to statistics, okay, we are finally done with that. We're moving on to our next units, logic, sets, and probability. All right. And we're going to start with an introduction to sets. So what is a set? It is any well-defined list or collection of objects. Okay, any well-defined list or collection of objects. Okay. Now we have, you probably remember this from algebra, specifically algebra 1, algebra 2. We have what's called set notation. Sets are denoted with a capital letter. The items, names, objects, or numbers are enclosed in the squiggly brackets here. Okay, so set notation, as we're saying here, okay, it's going to look something like, maybe all x. And then it said that this bar means what? Such that, and then you would have your restriction. Maybe x belongs to the real numbers, whatever your solution set was trying to tell you. Okay. Now, in place of that vertical segment, does anybody know what we could use instead that means the exact same thing? A colon, there you go. So in place of the vertical bar, you could put a colon and it means the exact same thing. Okay, and then another example here, set F is all values of x such that x is odd. Okay, now there is such a thing, what we call the empty or the null set, where you can just write the brackets with nothing in between them, or you could go ahead and write 0 with a slash through it. And typically that's what most people prefer to go ahead and do. Now, I want to say it was the first week or the second week, we talked about a classification of the values that we have, the hierarchy of real numbers, when we talked about significant figures. Do you guys remember that? Okay, if you do, great. If not, well, here are a lot of those classifications again. So n, we refer to them as the natural numbers, but there are some differences here. In IB, there are no whole numbers. Basically, the whole numbers have become the natural numbers. Because what was the big difference between whole and natural? Whole had what extra element? No, negative, 0. Whole had 0. So here, we just go ahead and call them natural numbers, and it's your counting numbers that you first learned way back in elementary school, kindergarten. So n is going to be 0, 1, 2, 3, 4, and it's going to continue. So we also call those cardinal or natural numbers now. Z is the integers. So this is where we have 0, your positive counting numbers, and their opposites. Q is your rational numbers. So according to our previous definition, we'll read this as set Q, our rationals, are all values of m such that m is equal to a fraction. Okay, where both a and b belong to the integers or are a member of, that's what the curvy e means, pretty much belongs to. And b cannot be 0. And that makes sense because what's the one thing you can't divide by? Can't divide by 0, so we have that restriction there. And then r, of course, is going to be all the real numbers, so any value you can think of. So the cardinal number of a set A, that's an A right there. Yep. The cardinal number of a set A, or n of A, represents the number of elements in a set. Yep. Can't write today. So when we're talking elements, we're talking to the actual number of objects. So the actual number of values or items, whatever it is, that's contained in your set. So for example, if I had something like set A is made up of, let's say, even numbers to 10. Okay, 2, 4, 6, 8, 10. Okay. Well, if I see this notation, n of A, what would that equal? 5. Okay, so when you see that n, that refers to the exact number of elements, items in that set. So see, I have 1, 2, 3, 4, 5, so that's what that refers to. Okay, so the number of items in that set. Now, a finite set has a countable number of elements. Okay, Like this one right here would definitely be finite because I can definitely count to 5. But an infinite set has an infinite number of elements. Like if I were to go back up here, this set, what I talked about at the very beginning, all values of x such that x belongs to the reals, well, there are an infinite number of reals. Okay, so that would be an infinite set. All right. And then the empty set is denoted as empty brackets or no solution symbol. So empty set. And what else did we call that? Starts with an N. The null set. We could also call it the null set. All right. I'll tell you what, we got that filled in. We'll just go ahead and pick up there tomorrow. Okay. Like I said, we're not going to get very far today, but at least we got the vocabulary words filled in. Okay. And then next thing we'll talk about subsets and proper subsets and start moving on into conjunctions, disjunctions, and all that good stuff.